So this is a quick summary of how to find the gradient of any line, which goes by many different names, such as the steepness or incline of the line. You may have heard it as the rise over run, or the change in y over the change in x. They are both the same thing, mean the same thing, they're just different ways of remembering it. Now, you can have three different possibilities of gradients. You can have a negative gradient, which just means as you go along, you go down instead of going up, which just generates a negative gradient. You could also have a zero gradient line, which means that there's neither an up change or a down change as you go along. Or you could have a positive one, which is obviously just the opposite of the negative, which you go up for every time you go along. Now, you probably have been familiar with this line equation, y equals mx plus c, m being the gradient and the c being the y-intercept. M being the gradient, again, is just the steepness of the line, how far it's moving for every time you move along the x-axis. How much you're changing in height as you move along the x-axis. And the y-intercept being where it crosses the y-axis. Now, the whole point of the y-intercept is to basically tell you where the line actually is, because you could have two lines with the same gradient but be at two different y-intercept points. So all the c does is just force it to be in a certain in a certain place, because it could have just been up or down anywhere along this line, but it fixes it where the red dot is. So that's the y-intercept. So let's get on to a question. What is the equation of the line? So straight away, we already know that our line always has to have the same kind of format, y equals mx plus c, as I've wrote down there. So as we said, our plus c was our y-intercept and our m is our gradient. So straight away, we should be able to find out what our c is if we've been given the graph, as our c will just be lying on whatever crosses our y-axis, and it crosses at exactly 1. So we already know that our y-intercept has to be 1. And now the gradient. So to find the gradient of any line, we need to have at least 2 points to figure out the gradient. And ideally, we want these numbers to be whole numbers, because as we said, the gradient is rise over run, or the change in y over change in x. So if we end up getting two decimal numbers, so like 4.2 and like 3.6 as an example, these numbers are hard to calculate with and deal with. So we much rather have whole numbers where it's 4 over 3 or 2 over 1, something like that. That's just very easy and not too difficult to deal with. And also, ideally, if we can get the numbers, so number 1 being whole, and also being in this area, this quarter of the graph, that would be the most ideal situation, since both of our numbers are positive, or all of the numbers that we're dealing with are positive, and they're whole numbers, so it makes our calculations much easier to do. Now, if we are able to look at our graph, we should find certain points that are very easy to read and to determine their coordinates. For example, this 1 and 3, this 0 and 1, minus 1 and minus 1, and minus 2, minus 3. So as we said, we're trying to be inside the top right corner. So we've got the easiest way to do this is we've got these 2 points here, this one and that one. So that coordinate is 1 and 3, and this one is going to be 0 and 1. So calculating our gradient, rise over run, this is the reason why it is used so much, is because we've got a rise in height over our run along the x-axis. So we're finding out the change in our height divided by our change in our x. So, and this is very important. We need to keep whatever we're finding the changes in very consistent. So otherwise our calculations will be wrong. So we've got 1 and 3 minus our other coordinates, which is 0 and 1. And obviously these are being our y coordinates, and we've got our x's there. So our change in y is finding out the difference in height from 3 to 1. So 3 minus 1, which gives us the change in 2. And we have to use the same coordinate, x coordinates, to be minused away from each other. So then we got 1 minus 0. Since we got 1 minus 0, which gives us a distance of 1 along. So ultimately, we have 2 over 1, which gives us a gradient of 2. So our line actually, for every 1 along it goes 2 up. Which makes sense, because that is what our graph is doing. So our final equation of the line is y equals 2x plus 1.